Hi everyone, so this is me Ankita Menon and welcome to this new module on physical chemistry. So in this series, we'll be covering the chapter Surface Chemistry. Surface Chemistry. Now see, this is one of the easiest chapters in physical chemistry, but it's also one of the most important chapters from an exam perspective. Okay, now see if you compare. Let's say you're targeting for CSIR exam. Now for CSIR exam, you can expect a minimum of 4 to a maximum of 6 marks from this particular module. And with regard to GATE, we can expect 1 to 2 questions. So this is the general trend. So if you understand the concepts well, this can be one of the, promising topics in your preparation, which would give you marks. So let's start with today's topic. We'll be starting with the difference between absorption and adsorption. If you can see, it is written at the bottom, absorption versus adsorption. Now, see, what is absorption? If you look at the images itself, it is very clear. Absorption means if you have certain substrate, which is shown in brown, cream color, that substrate holds the molecules in such a way that it is assimilated through the bulk, meaning these white balls are entering into the bulk of the system. This is absorption. Okay, so to define, absorption is the assimilation of the molecular system, whatever it is. So here it is represented by white balls. So these molecular systems enter into the bulk of the substrate. It can be solid, it can be liquid. Okay. While on the other hand, adsorption is where there is accumulation of species, whatever. So here we have represented that with white balls. That is present only on the surface. Only on the surface of the substrate. Right? So this is the major difference between absorption and adsorption. So let's write it down, the definition. They won't ask the definition, but this is just for your understanding. Okay. So absorption, you can create 2 columns and then please start. Absorption. Write down the heading, absorption versus adsorption. Absorption is a bulk phenomenon. Correct? Why is it a bulk phenomenon? Because here, whatever molecular system that we are considering enters into the bulk. For example, let's say you take a sponge and then you dip it in water. What can we see? We can see that the water enters the bulk of the sponge. Correct? It does not remain on the surface only. It enters completely into the bulk, and hence this is an example of absorption. While adsorption, on the other hand, is a surface phenomenon. This is a surface phenomenon. Okay. Now, to define, the bulk phenomenon is defined as assimilation of the molecular system throughout the bulk of solid or liquid. So by now, I hope you have an understanding that when you dip a sponge inside water, we can see that the water, which is the molecular system over here, enters into the bulk of the sponge. And this is an example of absorption. This is an example of absorption. Next one, a surface phenomenon, let's say painting of walls. Painting of walls. So when you paint, what can we see? We can see that the paint is stuck only on the surface of the bricks or the wall. It does not enter into the bulk. Correct? So that is an example of surface phenomenon. We can write it now. So here that is the accumulation of species on the surface of substrate. If you want, you can support it with the examples. Example, painting on a wall. Here, if you want to give an example, absorption of water by sponge. Okay. Next point. Absorption occurs at a uniform rate while adsorption increases steadily and then reaches equilibrium. Why does it reach equilibrium? We'll see that. All right, so this is about absorption versus adsorption. Very easy. Adsorption is a bulk phenomena wherein you have a system of molecules entering into the bulk. For example, when you dip sponge into water. And whatever absorption is taking place, it happens at a uniform rate. Correct. But then if you talk about adsorption, here it is a surface phenomenon, example painting on a wall. And what happens is the surface absorption increases to a point and then it attains equilibrium, and we'll talk about this in detail through different laws. We'll be talking about that. Okay, so I hope now you have got an understanding of what is the difference between absorption versus adsorption. And this is what we have to carry forward. Okay, that means so whenever you talk about adsorption, there are two components. So the first component is adsorbent. This, if I have to write it over here, I'll reduce the size. This is adsorbent, which means the component on the surface of which adsorption takes place. So you can see a ball, and on the surface of a cream ball, you can see white balls, correct? So the white balls are being assimilated on the surface of the cream ball, and hence the component on the surface of which adsorption takes place is called adsorbent. And whoever is being adsorbed, that means these white balls, these are adsorbate. These are adsorbate. Okay, so let's note that down. Adsorbate and adsorbent. So adsorbate. Adsorbate is the component being adsorbed, and those components can be solid, liquid, even gas. While adsorbate is what we have written. Next one is adsorbent. Adsorbent is the component on the surface of which adsorption takes place. This can be solid or liquid. Okay, this can be solid or liquid. So I hope that is very clear. It is clear from the diagram itself. So the component on which the adsorbate molecules rest or get assimilated is called adsorbent, and the molecules who get adsorbed are called adsorbate. Okay. Next one, Mainly for your syllabus, what you have to learn is about the adsorption of gas on a solid surface. Okay, let's say you have a very solid surface, and onto the solid surface, there will be gaseous molecules who get adsorbed. And this is what you have to learn in detail. So write down the next heading, adsorption of gas on solid surface. This is what we have to learn in detail. Okay. Now, depending on the interaction between the gas and the solid surface. Okay, so we can see that one who is getting adsorbed, the gas is getting adsorbed. So whoever gets adsorbed is the adsorbate. And the surface on which the adsorption happens is the adsorbent. Correct. So by now we know this. Now, depending on the interaction between the adsorbate and the adsorbent, depending on the interaction, there are two types of adsorption. One is physisorption. And the next one is chemisorption. Physisorption and chemisorption. These two types of adsorptions are based on, it depends on what? It depends on the interaction. Depends on the interaction between adsorbent and adsorbate. Okay? Adsorbate. There are two. Now we have to learn the differences between physisorption and chemisorptions. Very important. You get a lot of questions from this. Okay? So you can divide your page to 3 columns. First one would be property. Second column would be about physisorption. And the last one, chemisorption. So from the very name itself, you can understand that in physisorption, the interaction between the adsorbent and the adsorbate, they would be just physical interactions. While in chemisorption, the interaction between the gas and the solid surface would have chemical bonds. So that is already very clear from the literal meaning of the words itself. So let's start the first property, forces of attraction. Forces of attraction. So under physisorption, as we know, it has got only physical bonds. No chemical, only physical interaction. You cannot call physical interaction as a bond, I'm sorry. They are composed of just physical interactions, just very weak van der Waals forces of interactions. So there are no bonds. Correct? So you can write it down. No bond formation. No bond formation, comma, interactions through weak, very important. Physisorption, under physisorption, the gas when adsorbed onto solid are held by very weak forces of attractions. Which are the weak forces of attraction? Weak van der Waals forces of attraction. Okay, while under chemisorption, there is a formation of the bond. Bond formation exists, okay, leading to strong forces of attraction. Strong forces of attraction. Right? So here we have weak van der Waals forces, and under chemisorption we have strong forces of attraction. Why? Because there is a bond formation. Okay. Now, next one, heat of adsorption. Heat of adsorption. Heat of adsorption. Now, understand that adsorption process is exothermic. So if you can observe, see, when you sit inside a room which is freshly painted, you can feel that the temperature is slightly increased. Okay, that is because when adsorption takes place, it releases energy out. It releases the heat outside. So you can write it in brackets over here that adsorption is an exothermic process. Okay, whether it is physisorption, whether it is chemisorption, it will always release energy. And the amount of energy which is released is what makes the difference. So usually under physisorptions, as there are no bonds in particular, the heat of adsorption which is released would be less compared to that of chemisorption. So you can note it down. Here it is approximately 10 to 40 kilojoules per mole. And under chemisorption, it is nearly 150 to 400 kilojoules per mole. Okay. So there are various textbooks which shows varying, options. So in some textbooks, they have also written 10 to 25 kilojoules per mole. And here they have given a range of 150 to 250 kilojoules per mole. Just understand that the heat of absorption, which is released by the systems that undergo chemisorptions, are usually higher than that of the physisorption, and that is the takeaway. Okay, that is the takeaway. Next one, reversibility. Reversibility. So by now you know what is reversibility. Reversibility means, see, you write it down over here, then I'll explain. Reversibility is physisorption undergoes reversible reactions because no surface compounds are formed. No surface compounds are formed. Okay, no surface compounds are formed. While chemisorption is irreversible. Why is this irreversible? That is because surface compounds are formed. Okay? What do you mean by surface compounds? That is, let's say you have a surface. This is a solid surface, onto the top of which there is a gas being attached. Now, through physisorption, there won't be no change happening to the gas if it is physisorption. Now, let's say there is a part or there is a process where it undergoes chemisorption. So, chemisorption can lead to, let's say it was G, and we know that it forms a bond with the solid surface, correct? It changes. It changes to something else, like G prime. So, what happens? Then it is no longer reversible. Even if you release it, you get G prime, which is entirely something different than G. Reversible means, let's say you have A plus B forming AB. Then upon reversing it, you should again get A plus B itself. That is the meaning of reversible. Irreversible means you won't be able to generate the parent species. That is reversible. Okay. Next one, the rate of the reaction. The rate of the reaction. Of course, physisorptions are quick. They are rapid. While chemisorption will happen only slowly. Why? Because they have bond formations happening and that will take time. Next one, activation energy. Activation energy. Physisorption requires no activation energy because only physical interactions. But for chemisorption, as it is associated with bond formation, a definite amount would be present. Definite amount of activation energy would be required. Okay. Next, dependence on temperature. Last 2 points are very important. Dependence on temperature. The way it depends on temperature is, you note it down. For physics option, as your temperature increases, so this notates increases, okay? As your temperature increases, your physics option decreases. Why? Because the molecule cannot stay there. They are very weak interactions. And once you give some heat, once you increase the temperature, it will fall off. It will fall off and desorption happens. I hope you understand what desorption is. It is the opposite of adsorption. Okay? Desorption happens. So as temperature increases, we'll write it down. As temperature increases, physisorption decreases. While for chemisorption, as temperature increases, chemisorption increases initially and then decreases. Very important. Why? Because, see, for chemisorption, we already said that it requires some amount of activation energy. So when you give temperature, we have already learned in chemical kinetics that when you provide a temperature to the system, it enables to attain the activation energy quickly. Correct. So as the temperature increases, the chemisorption increases initially, but then it falls down. It has got an optimum value beyond which it won't work. Second last one, pressure. As pressure increases, physisorption also increases. Why? Because pressure means you have a solid surface, you have a gaseous molecule, you are pushing it. You are pushing the gaseous molecule closer to the solid surface, so the assimilation will become easier. So as pressure increases, physisorption increases, and for chemisorption, there is no effect. Last one, number of layers. And physisorption, you can see multi-layer being formed. Chemisorption, as it involves bond formation, only a single layer. Okay? So if you have a chemisorption, this is a solid surface. Onto the solid surface, you have a gaseous molecule. There's just one layer. Okay? There is just one layer. That's it. But for a physisorption, so these are bonds, okay? All these are bonds. Physisorption means you have the first layer, weak van der Waals forces, and then you will have another layer which has got even weaker van der Waals forces. It will pile up. Okay? So this is multi-layered while chemisorption is single-layered. Very, very easy. So that's it. So the core differences are highlighted over here. Very easy. Forces of attraction of physisorptions are weak because it has only weak van der Waals forces. Heat of absorption is low. It is reversible, happens rapidly. No activation energy, depends on temperature inversely and directly proportional to the pressure with multi-layered formation. Okay? And corresponding to the chemisorption, it has got very strong forces of attraction, very high adsorption energies, irreversible because of the bond formation, happens slowly, has got a definite amount of activation energy, and it increases with the temperature initially, but then drops, has no effect on temperature, and forms only a single layer because it has got bond formation. Okay. Now again, we are going to list some factors that affect physisorption. Okay. Listed down factors affecting factors affecting physisorption. Factors affecting physisorption. Okay. So the first factor is temperature. Temperature. We are talking about physisorption and not chemisorption. Physisorption. Okay. Now see, if you have a gaseous molecule which is being adsorbed on a solid surface, we said that physisorptions are reversible. It reversibly forms a gas-solid complex and it releases heat because adsorption is exothermic. Because this is exothermic. Okay? We already said that. Now, in the comparison table, we said that as temperature increases, the physisorption decreases. Why? Why? Because, see, according to the Le Chatelier's principle, if you increase the temperature, what happens? Now, see, already this is an exothermic reaction. So, for exothermic reactions, if you increase the temperature, what happens is temperature means it's a form of heat. Temperature is a form of heat. So, when you externally increase the temperature, the whatever products that you have, let's consider GS as one of the product and heat as the byproduct. Okay. Now, when you increase the temperature, which is also a form of heat, you are increasing one of the byproduct, which is on the right. So there is an imbalance. Okay. There is an imbalance. There is an imbalance because of which, as this byproduct increases, the reaction which is, the reaction will tend to go to a direction where the heat is reduced. So it will go back. Let me repeat it once again. So see, we already said that physisorption is reversible in nature. So this is a reversibility sign and it also attains equilibrium after a while. We said, correct? Adsorption attains equilibrium steadily. We already said that. Now, when you increase the temperature which is a form of a heat, is one of the byproduct of the reaction. So this reaction has got two parts. This is the forward reaction and this is the backward reaction. Correct? Forward reaction is where you form GS and heat. Backward reaction is where you see the desorption happening. Or in other words, I can say that forward is adsorption, backward is desorption. Now, when you increase the temperature, which is a form of a heat, what it tends to do is the products on the right-hand side increases. The system is under equilibrium. It will try to reduce the products which are formed now. Because you're increasing the temperature, the heat is high, the products on the right is high. So the system tends to move towards left. So that this increase is compensated. So it tends to move towards left and hence desorption happens. Okay? So I hope that is clear. If it is not clear, please replay it again. All right. So as temperature increases, desorption increases. Or in other words, what we can see? Adsorption decreases. I hope you understand what is the reason. So your products on the right, they are increasing. The system will try to reduce the amount of the product. If it has to reduce it, it has to push the reaction towards left. And if it moves towards left, GS will depart to G and S, meaning desorption happens. Okay? So this is in accordance with the Le Chatelier's principle. Next one, next factor. If you want, according to Le Chatelier's principle. Okay. Next one is pressure. Again, let's take the same conditions. We have a gas being adsorbed on a solid, attaining equilibrium with GS. That is the gas-solid complex. Again, according to the Le Chatelier's principle, you write it down and then I'll explain. According to Le Chatelier's principle, increase in pressure shifts, increase in the pressure shifts the reaction to the side with lesser number of moles. Okay. So see, according to the Le Chatelier's principle, it says is that if you have a reaction which is under equilibrium and you increase the pressure, so if you increase the pressure, the reaction always shifts towards those side where the number of moles are less. So here there is 1 mole of gas and 1 mole of solid, whatever it is. So on a total of 2 moles. Here you have only one complex, 1 mole. So what will happen? If you increase the pressure, the reaction shifts towards right. Now, what is happening towards right? Adsorption is happening, correct? So what can we write? For physisorption, as pressure increases, adsorption increases. We have written this already in the column. And we are giving an explanation based on the Le Chatelier's principle, that's all. Okay, based on the Le Chatelier's principle, this is how we explain it. Okay, next, nature of the adsorbent. Nature of adsorbent. Now see, the adsorbent is the surface on which adsorption happens. It is directly proportional to the surface area. That's all. Okay? Adsorption increases with surface area of the solid. If you have a system with, let's say, 1 meter square, and if you have another system, let's say it has got 10 meter square surface area, the adsorption will be higher for 10 meters square. That's why you always, instead of taking chunks of charcoal, you always powder it. Okay, you always powder it. Why is always charcoal, which is marketed for adsorption again, it is powdered. Why? Because powdering increases the surface area. Powdering increases the surface area. Okay. Okay, fourth one. Nature of adsorbate. Nature of adsorbate. Now, adsorbate is the molecule which gets adsorbed onto the surface of the solid. And that depends on, you can write it down, liquefiable gases. Liquefiable gases adsorb quickly than permanent gases. I'll give examples. Liquefiable gases adsorb quickly than permanent gases. What are the examples of liquefiable gases? The examples are NH3, HCl. So these are those reactions or gases, not reactions. These are gases which can be liquefied when given pressure. Okay. And for permanent gases are H2, O2, N2, hard to compress or liquefy. Okay. So the liquefiable gases, they adsorb quickly. Okay. gases like NH3, HCl, they adsorb quickly. Why do they adsorb quickly? Because they liquefy easily. Liquefy easily means they interact well. You know that the forces of interactions between a liquid phase is higher than that of the gas phase. So here, gases like NH3 or HCl, they adsorb quickly due to hydrogen bonding and other interactions. Okay? And other interactions. So when you have better interactions, better is the physisorption, and hence liquefiable gases are better in adsorption than permanent gases. Okay, so with this, we'll wind up this video and we'll be seeing in the next. We'll practice some problems based on whatever is asked from this session in the next, and then we'll continue with the lecture. Okay, so I hope you have understood. If you have any queries, please let me know in the comment box. You can chat, and whenever possible, I can, get back to you and answer to your questions. Okay, so bye. See you.